Hello everyone, it's October 23rd. Alright, yesterday was weird. I wasn't in the best mindset to do it, so it was quite bad. So yeah, I'm gonna regroup. I'm gonna do today's challenge first, and actually I took some time yesterday to think about this. I'll talk more about this, and I actually have I play around with the test case, and man, it's kind of cheating, right? But I'm just trying to um, find the rules here, and I think I got it. I think I found it. So I'm gonna try. I haven't submitted anything yet. Right, I haven't submitted anything yet. So I'm gonna try this idea of DP, and most likely this type of problem is DP, and see if it works. But if it works, it's actually a very simple solution. So I'm gonna do this. But first of all, let's try this thing. Oh, apparently we've done this before. Oh, before going into it, and I've been reading the book, Just Mercy. I saw the movie a few years ago. Dude, it's so sad. It's so sad. I mean, books like this, stories like this, really get you to think about what's the purpose of prison? What's the purpose of doing all this? I guess we shouldn't be doing this because we hate people. There's just too much hate, right? There's a lot of hate, and the laws set up, but it's not followed because people just do things nilly-willy because of this hate. And you kind of think the stories happened in the book was in the 1980s, right? Early 1990s. But the same thing I'm pretty sure is still happening now, right now. Yeah, sometimes, you got frustrated and then you kind of think, how is it possible that humanity has lasted this long? But we have. And I'm also pretty sure that back in the old days, it was even darker. But we just kept going and strive to be better. Man. And I'm also reading the Expense series, which was quite realistic, thinking maybe in 100 years, maybe some things will happen, and it's a very different um, scenario, and I'm thinking that it might be possible for us to evolve to that kind of state is quite marvelous, and yeah, sometimes you think, is it possible that we can ever reach that stage before we destroy ourselves? I don't know. All right, anyway, so let's get on to this one. Maximum length of a concatenated string with unique characters. Given an array of strings, string S is formed by concatenation of a subsequence, oh my god, subsequence again, of array that has unique characters to the maximum possible length. Wait, what are we trying to do? Unique characters. A string S is formed by concatenation of subsequences of array. So it has to be subsequence that has unique characters, the maximum possible length of S. So the S has to be unique. So I can do U and IQ. I can do IQ UE. But I cannot do UN, IQ, and UE, right? So this one we can do. So are they all unique by themselves? Concatenation of subsequence of array that has unique characters. Yeah, so everything I think is unique. So I can do this, CHA, so I cannot do this because it has A, but I can do this, right? Or I can do this together. I can do R, but that's shorter. Okay, so look at the length. It's only 16 in length. I might be able to get all possibilities. Yeah, seriously, I think this one can be solved brute force. Yeah, and this is 26. This can be solved by brute force. Maybe brute force is the solution for this. So basically just each one you either take or you don't take, right? And we can just BFS to the end. Let's see, what would be the easier way? We can throw, I mean, we can probably just concat, right? We say, yeah, we say we take this. So everyone, we take it or we don't take it, right? We take it, and then we go to the next one. Then we say if this is inside it. Like seriously, we can just do inside, just do in, because the string will not be longer than 26, because it has to be unique. The string won't be longer than 26. So we can brute force this. I'm not sure if this question is set up for brute force. Maybe it is. Maybe it is not. But I don't know. Let's just brute force this. That'll be fun. Yeah, maybe I shouldn't delete math. So if brute force this, we need a DFS, right? We need a, what do we need? We need index, right? And then current S. And then that's it. We don't return anything because we'll have max length will equal to 0 and the rest will equal to this. And now we say if, that's fine. If index is equal to len, actually it shouldn't go to the len array as we can check every single time. Right? We check every single time. Like we concat, we check it. Right? And then going to the end. Yeah, we just return. This one we just return, right? Otherwise, we say if, I mean, we might as well just check every single one. We definitely can check every single one. Or instead of the current S, we make it into a set. Okay? And then we check each one in a set. Okay, S set. And actually, what your res? I only need a length, right? A set. Then we say for letter in array index, right? We say if letter is in S set, then this one cannot take. Then we break, right? So basically we're trying to say if it can take. So else means it can take. Then we just do, what do? We do DFS index plus 1, right? And then we say S set dot union set array index, right? And then we can always do don't take it, and then do the same. Wait, hold on. New S set, right? And then we say if len new S set is larger than res equals len new S set, and then we keep going on. Otherwise, we just don't do it. And then we run 0 and just a set, initial set. And we return res. I think maybe it'll be better just to self.res. I don't know. Let's see if this one works. So we say this should be 4. Oops. And this should be 6. And this shall be 26. Actually, we can break early if it is 26. Right? Yeah, we can just say if any time is equal to 26, then we just don't do it. Yeah, we can say if this or self.res is equal to 26, we just return. There's no point of keep doing it. Well, because the maximum we can get is 26. Oh. Max length. Self.res. Yep. I'm pretty sure that's the solution because I don't think there are other ways. You just, oh my god. Man, the track record was pretty bad. This shall be 0. Oh, we need to check it first. Holy guacamole. Alright. And what do? Well, we need to set it anyway, right? So we can do, oh, you know what? We do this like this. We have sets equals to for W in array. I don't want to do it twice. For word in array, word set equals set W. If len set W set is equal to len W, then array sets.append W set, return to a set. And then we're gonna handle the array sets. So we don't have to do this because I already done it. So we just say len array sets index. All right? Yeah, this is gonna be array sets is larger than. No, come on, that's not right. This is array sets. New set should be s.set union array set. Right, we union the two. I think we can do it even better. We put it here. We always union the two, right? And we say if len this equal to len sset plus len array sets index means it's all unique. Then we can do if this. We update, we keep going. Otherwise, we go this. Nope. Array set is not defined. Yeah, of course, it's array sets. What's the problem now? Index out of range. Oh yeah, index is out of range. So we can do here, we say if not, array sets turns 0. There we go. I'm pretty sure I probably got it wrong in the same spot last time. Runtime error, list index out of range. Wow. Holy crap. How? Well, this one is index. Oh, God. Then array sets. Oh, if that's the case, maybe I don't even need to. Yeah, I don't even need to have this. Oh, I don't know the answer here. Yep. But we're gonna try. We don't need this. Yep. Too fast. Trying to do it too fast. This is the kind of the result. I mean, it's also possible that we don't have to do it here, we just do it here. But it's the same, right? It's the same thing. It's an easy problem anyway. Not difficult, because the constraint on the size of array is very small, only 16. This means we can brute force it by going through all 2 to the 16 different combinations. The difficulty is that, what's the difficulty actually? Is that the input could be unsanitized. That is, input string has duplicates themselves. Thus, we must clean that before going through the DFS part. Okay. Same idea. Okay, so we're done with this. All right, let's go back to this. Actually, I never really started. So let's start. 940. So the idea is DP, right? So it's like this. We're using this ABC as an example. So what we'll do is let's call DP is equal to this. Okay. We're going to do this to 0 times len s, and then dp0. So dpi is the total number of unique subsequence things, right? Subsequences ending at I, position I. So this will be 1. Okay. Well, in fact, it'll be easier if we do this plus 1, right? And then what we can do is, yeah, we shift it a little bit. There's a benefit in this. And then as we go, right? So A is 1, and then B, so the total number that ending in B is the total number ending in A plus B itself. So total number ending in A is 1, and then B itself 1. So this position will be 2, which is just B and AB. And actually it's 3, because I have to add this one as well. So total ending in B is 2, adding the previous one, so that would be 3. C is the same. So previous is 3, and adding 1, so C will be 4, ending in C, plus previous 3, so that's 7. Now the difficult part is now we have an A coming in. So when A comes in, we have to remove the duplicates. And the duplicates happens, if you take a look, we have this is A, and this is also A. So whatever subsequent that ends in this A, right? And those subsequents ending in that A will be duplicate. So we just need to find the total number of subsequents that will end in this A. And then we remove that from this. So we find the total subsequents ending in this A is only 1, right? Just A by itself. So with that, we say, okay, this is just going to be, everything here is 7, right? But we should plus 1, we minus 1. So in fact, with that, we can just say, if this has occurred before, so we just never count itself, we just count how many is ending in A. It's actually, that is 0, right? Because A is the first one. So this one we just plus 14. And for this B, we find this B. And this B has 1 ending, like 1, except for B itself, 1 subsequence ending in B, right? So that one will duplicate here. So I just remove that one. So that becomes 14 minus 1 be 13, right? So that's how that goes. And when we have multiple, right? We have multiple, like we have this B. So now this question is, with this B, which B to use, right? Which B to consider? So from trial and error yesterday, it should be the last B, which makes sense because everything, because this is the most recent appearance of B. So everything subsequent to ending in this B will also be duplicated in here, right? Doesn't matter about this B, however, like just overall ending this one will be duplicated here because ending in this one will also be ending in this one, right? It's the same. So they're the unique ones ending in this one. If we allow them to stay to ending this one, then we have duplicates. So we just find how many is ending in this, and then we remove it. So with this, we'll have our dp, right? And then we also need to keep track of the last occurrences. So we say last seen. And I would just use a dictionary, but in fact, we can use anything. We can use a, I don't know, we can use a list, but I don't like lists. I like dictionary. Okay, so with that, we can say for, we can say I letter. Do we need I? We probably don't. We do need I. So for I letter in, right, in enumerate S. Okay, and then we say if letter is not in last seen, all right, then dp I plus 1, because it should be 1 index and this is 0. So this one shall equal to dp I, so the previous one, so all of that plus 1 plus by itself, and then, so this is the current, plus dp1, so we can say 2 times dpi plus 1. And then we say last seen letter is going to equal to I. Index is the last seen index. All right, if it's not last seen, then that's that. Else, if it has been seen last, then dpi plus 1 shall equal to dpi, right, everything, and plus 1 minus 1, so we cancel that out, minus dp last seen letter, right, but we have the plus 1. No, actually, just that one, because if we don't handle this, it's the previous one, right, the previous one. So it's going to be this, right, and then plus dpi, so 2 times, right, so blah, 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 and then we eventually return dp minus 1. So this is apparently a very simple solution, and we will like to verify. What the hell? Oh, keys are not working again. There you go. That's 7. Yeah, we can actually do ABC, ABC. Actually, do ABC, AB. You can put it here, ABC, ABC A. I will do ABC A, which is 14. Yes, 14. And then ABC, AB, 27. ABC, ABC, I remember it's 51. And then 95, right? 51. And then this is 95, 176. And then this is 325. Okay. And then throw in a few more ABA, 6. AA shall be 3. Now I never tested the last two, so if it doesn't work, we will know. S. Ooh, this ain't work. That's weird. How? I was following the exact logic. That's weird. Yeah. Let's print DP and the last scene. Let's take a look, see where it goes wrong. 14, 27, 51. Should be 95. Why did it become 120, 102? 102. That is because it's A, right? So last scene should be, it should now be 0. Oh, I forgot to update last scene. My bad. My bad. We need to update last scene. That's true. Need to always update. There we go. Okay. So yeah, I say a little bit cheating, but I did figure it out myself. Ah, I forgot to mod. Yeah, this is frustrating. No question about it. It's on. So yeah, we solved this. I did check the hint that this problem is DP, and I also used trial and error to find the rule, the pattern of DP. But overall, I still figured out the DP mostly. I still consider this problem solved by myself with a bit external help. So the idea is to use DP, right? The idea is to use DPI to represent the total number of unique subsequences ending in SI. And for SI plus 1, if there is no occurrences of SI plus 1 or 4, we simply record DP I plus 1 equal to 2 times DPI plus 1. However, if SI plus 1 occurs before, and we need to remove all potential duplicates, right? That are the same when ending in the previous existing SI plus 1 and the current SI plus 1. Now the number of such duplicates of these duplicates is DPI, right? Which is the total number of unique subsequences right before the previous, no, is DP as before. Let's say it has occurred at Sj. That we need to remove all potential duplicates that are the same when ending in the previous Sj, right? Sj, and the current this. Number of these duplicates is dpj minus 1. Number of unique subsequences right before the previous Sj. So dpi plus 1 shall equal to dpi plus 1, dpi plus 1 plus dpi, right? So this one will be the same, equal to this, right? This current plus dpi minus 1 minus dp j minus 1, right? And don't forget to mod. So on, it runs in on. Have a very good runtime. Oh yeah, we can do this one first. That's true. Uh-huh. Oh yeah. O1 space. How is O1 space? You have a last count. Oh no, it's fine. It's a DP. It doesn't have a DP. Then how do you get a DP last count? Oh, you find the number of sequences. I see. Okay, yeah. Yep, it works, but nah, I don't want to. All right, it's all right. It's not too difficult, but I did use some help. Okay, that'll be it. I actually say update. It is possible to solve this in O1 space, which requires that we do not use a DP table, DP list. Instead, we just keep pre, right? We just keep pre. In addition, we use the last scene dict to record the number of potential duplicates of the last scene letter instead of recording its index. You know what? Let's try this. It's different when you're trying to say, okay, I know how to do it. Now I'll write it. All right. So this is from inspired by. Let's put this person's share. Yeah. Okay, so pre equals 0. All right, last scene counts equals a dictionary, and then for and enumerate. So I don't even need, I just need this one. I think it would be sufficient, right? Say if letter not in last scene counts, then letter equals 2 times pre plus 1, right? Else letter, not letter, current, dude, current equals 2 times pre minus last scene counts letter, right? Once we done, last scene counts letter shall equal to pre, right? Last scene shall equal to pre, and then pre equals current. Can we simplify this? Yeah, we can just say current equals 2 times pre, right? And then we say current plus equal to 1 if this, else minus last scene counts letter. And then we update, and then we're going to return pre. Let's see. Yep, so this is a O1 space ON time. Very good. Oh, I remembered. In fact, it'll be easier just to record it here. Yep. Yep. All right, that's it. Done. See you guys tomorrow. Adios.